average value of a function. That's where we're headed today. We are integrating, okay? We just talked about in that grass clippings question that if you find this, if you find the integral of something, that is finding the area under the curve from A to B. It's taking all of those grass clippings from that last question and adding them up, okay? So this guy right here tells you the total sum of whatever you started with. So the equation we had in Bellwork was about grass clippings. So when I found the area under the curve, it was the total amount of grass clippings, which isn't what I wanted. Okay? I wanted the average amount of grass clippings. So if I gave you 2 tests, and on the first test you got 100, and the other test you got an 80, how would you find the average? Add them up and then divide by 2. That is average. That's exactly what we're doing here. There's nothing different than that. I gave you test scores. You took the test scores, added them up, divided by 2. I'm giving you something. I'm giving you grass clippings. You add them up. You find the sum. Okay, you do the integral, and then you divide by however many days you had, or divide by whatever was going on there. This will tell you the total amount of grass clippings, and then if we multiplied by B minus A, by the width, like 30 minus 0, it became pounds divided by days. It puts us back in what we wanted, the average amount of grass clippings. Actually, when we integrate it, it gets rid of the days, and then we do it again, it gets back to it. Okay, here we go. Let's look at this. Number 1 says find the average value of 4 minus x squared. We're finding an average value. To find the average value, to find the average of whatever this guy is, we are integrating. Okay, we're going to integrate 4 minus x squared dx. When am I going to integrate that thing from? 0 to 3. But that's not how I find the average value. That will tell me the total value. Okay, it'll add them all up, the change in value, I should say. That's the change in the value. What am I going to do to find the average? I'm going to multiply by 1 over the width. So 3 minus 0. Okay, so on your paper, integrate that thing. Do this by hand. Integrate 4 minus x squared. And then use FTC to find that answer. The fundamental theorem of calculus. Do what you do with definite integrals. Here we go. 4 minus x squared. If I tell you before you do it, then you don't pay attention. 4 minus x squared, the first thing we're going to do is find capital of f of x. We're going to find the antiderivative. Dylan, what's the antiderivative of 4 going to get me? 4x. 4x. And then, Harrison, what about the antiderivative of x squared?
Negative 1/3 x cubed.
Negative 1/3 x cubed. He increased the exponent divided by his exponent. Cool. He did that to define it. He's finding capital F of 3 minus capital F of 0. So capital F of 3 means 4 times 3 minus 1/3 times 3 cubed. 4 times 3 is 12. I'm going over here. 12 minus 3 cubed is 27 divided by 3 is 9. That gets you 3. What is F of 0 going to get you? 0. When you plug it in, it goes away. Yay for us. That goes away. And so my problem is 3 minus that. It's 3 minus 0. Is the average value 0? Or the average value 3? No, it's not 3. 3 is what the sum is. That is the area under the curve from 0 to 3. I want the average value. And so I'm taking that 3, and I am multiplying by this 1/3 in front, by this guy. So it's 1/3 times 3. That's where I'm getting the 1 from. That's the average value. Makes sense on that one. Let's look at the next one. It says the temperature in degrees. So they are telling me temperature. They're telling me Celsius in hours at the art museum varies according to that equation. Make sure your calculator's in radians because we're dealing with sine and cosine. Find the average temperature over that integral. So let's just set it up before we type it into our calculator. They gave me temperature. They're asking for average temperature. They gave you the thing you want to take the average of. If I gave you your test scores, you want to find the average, add them up, divide by 2, okay? Or divide by however many you have. So we're going to do that. We are going to add up all of the temperatures, okay? We're going to add up all of the temperatures of T. From when do I want to add up the temperatures? 2 to 6, because I want to know over that interval. So it's from 2 to 6. That will find the accumulation, the amount of temperature altogether, if you include positive and negative. The change in the temperature, or the total of the temperatures. Not what I want. What do I need to do with that? 1 over the width. 6 minus 2 or 1/4. Take out your calculator. Calculate that thing. Okay, so you're typing this in. It's not real complicated. One thing that I often forget is I will write it on my paper as 1/4 at the end, and then I don't do it. Okay, you can type it in beforehand and multiply by 1/4, or you can get the thing and then multiply by 1/4 at the end. It doesn't matter. Just make sure you're doing that 1/4, or otherwise it's not the average value. My average value is 22.387. Okay, so this guy right here is 22.387. Okay, what is my units going to be? That is degrees Celsius. Okay, it's degrees Celsius. When I add them all up, when I just found the sum, it becomes the degrees Celsius, and I take away a time. But then when I divide by time again, it gets me back to degrees Celsius. That's really hard to understand, but it makes sense in my brain. With your neighbor, write a meaning out for that. What does that mean? Write it out in a good AP format. What does that answer mean? What does that integral mean? So here's what he said. 22.387 degrees Celsius is the average temperature. And he said the good interval there from 2 to 6, and we're in hours, right? 2 to 6 hours. Think about what happened. Did you multiply that? Then it's average. So make sure you're setting that thing up. Do number 3. Try number 3. You are finding the average acceleration of that guy from 0.5 to 5. Go. In which of these intervals is there a value of c for which f of c is the average value of f over the interval? So this is a graph of f of x. Looking up there, let's break out some things. I want f of c is, so what else could we put for is? Equals f of c equals the average value of f. This is a graph of f. How do I find the average value of f if they told me what f was? No. What did we just do on the front side to find average value? I'm going to integrate f of x from when to when, would you think? 0 to 6, but that's not my answer. I want to find the average value, so I'm going to multiply that by 1/6. Find the average value of f. Look at that graph. Think what the integral means, and do that. Get an answer. To find this guy, I'm looking for the area under the curve from 0 to 6, so I'm going to break it up like this. Whoa. Break it up like this. Here's a box. It's 2 by 2, so that's 4. There's a triangle. It's half of that, so it's 2. That's a big old triangle. 4 by 4. Cut it in half. It gets me 8. And so when I add that all together, this gets me 14, but I'm multiplying that by 1/6. So it's 14 over 6, which is 2 1/3. Yeah, 2 1/3. So in other words, I'm trying to figure out when f of c is equal to 2.333333. What does f of c mean? Over the interval. Yeah. You're trying to figure out when f of c is equal to that. F of c means y. Think about that. Look at that with your neighbor. Get me an answer. Which one of those is true? Looking at answers, looks like we're doing the right thing. Answer looks to be D. Here's what I did to do that. I wanted to know when was f of c equal to this, so I graphed it. 2.33. There's 2, there's 3. And so I'm going to make a line that goes at a little bit more than 2 across my graph. So when did I cross it? I crossed it right here, which was on the interval between 0 and 2. And I also crossed it right there, which was on the interval between 2 and 4. So 0 to 2, 2 and 4, those are good. D is the correct answer. Average value. A tough looking question, but once we broke it down, it didn't seem as hard.